Okay, so we've got a pretty hefty stack of research here,
Yeah.
all about the St Helens Power Station in England.
It's quite a story.
Yeah, it looks like our listener sent us a little bit of everything.
Yeah, we've got
Powerful records.
a Wikipedia article.
Some old photos.
Looks like a good mix to really paint a picture of this power station's life.
Yeah. And you know how we do our deep dives?
Yeah.
I'm really excited to dig in and see, where it all began,
Yeah, trace its evolution.
how it grew and changed.
And ultimately, what led to its closure.
Right, so starting at the very beginning,
Okay.
we're talking 1894.
The dawn of the age of electricity.
Right, most people are still using gas lamps at this point.
Yeah, can you imagine?
It's hard for us to really grasp how revolutionary this technology was.
Totally.
And in this context, the St. Helens Corporation, they get permission to build a power station.
That's a big deal.
Huge deal, right?
Yeah.
But what's fascinating is that even with this brand new power station,
Yeah.
they only had 63 customers in their first year.
63 customers.
That's wild.
Think about that.
That's like maybe one block
Right.
of houses.
It really shows you just how expensive and inaccessible electricity was initially.
I mean, was this like a luxury?
Oh, absolutely.
Only for the wealthy?
Yeah, a luxury for the few.
Yeah, because I see here,
Yeah.
they were charging 6 pence per kilowatt hour.
That's astronomical in today's money.
It's mind-boggling.
Yeah,
So not exactly a bargain.
not at all.
Right. But then just a few years later,
Yeah.
1897,
Okay.
they decide to build a whole new power station at Croppers Hill.
That's interesting.
Yeah, why do you think that was?
Well, the St. Helens tramways.
The trams?
Yeah, they were switching from steam to electric power.
Oh, wow.
Yeah,
So they needed more juice.
exactly. It's a classic example of how technology drives infrastructure development.
Right. You need more power to run those electric trams.
So you build a bigger power station.
Domino effect.
It all connects.
Yeah, fascinating. So as more people in businesses started adopting electricity, the St. Helens Power Station just kept expanding, right?
They were constantly adding capacity to meet the growing demand.
I mean, can you imagine trying to manage that growth?
It must have been a whirlwind for them.
It's trying to keep up with the times.
Yeah, and the technology.
I mean, we see here that they installed new turbo alternators in 1911 and 1912.
Yeah, trying to stay ahead of the curve.
Always innovating. And then we come to the 1926 general strike.
Oh, this is a fascinating story.
Yeah, the sources you sent show that the local authorities actually went against the Labor Council
Why?
to keep the power station running.
That's really significant.
Yeah, what do you think that tells us?
It shows you just how essential electricity had already become to the community.
Right? It was more than just a convenience at that point.
Yeah, it was a lifeline,
Power struggles.
literally and figuratively.
Now, the tram system was decommissioned in 1936. What happened to the power station then?
Well, that's a great question.
Did they just suddenly have this huge surplus of electricity?
It makes you think about how transportation needs were shifting and how that affected energy demands.
So they might have had to adapt.
Yeah, find new customers, maybe scale back production.
That makes sense. And then in 1948,
Yes.
we have the nationalization of the British electricity supply industry.
a pivotal moment.
Yeah, what did that mean for St. Helens?
Well, they were no longer just serving a local community.
Yep.
They were now part of a national grid,
So their operations
subject to broader policies.
were being dictated by these national bodies like the British Electricity Authority.
Exactly.
Wow, so let's take a little virtual tour of the power station.
Okay.
I'm kind of picturing those early Robey engines
In that original.
in the original 145 kilowatt plant.
Such a contrast to what they had later.
Yeah, I mean, by 1923,
Mm-hmm.
they had expanded to a generating capacity of 11,800 kilowatts.
Huge jump.
Massive. And they were even providing different types of electricity supplies.
Yeah, AC/DC.
Traction current.
They had it all.
So different plugs for everything.
Can you imagine the adapters?
Yeah.
It must have been a nightmare.
But it shows you they were catering to a variety of needs, right?
Absolutely. Lighting homes.
Powering trams.
The whole work.
And then by 1954,
Okay.
they had these massive Babcock and Wilcox boilers,
Yeah.
huge cooling towers.
Now, this is interesting.
Yeah, what is it?
The sources you provided, they don't just list the equipment.
Uh-huh.
They talk about 6 wooden cooling towers.
Wooden. I mean, that must have been a sight.
Imagine these towering wooden structures
Like something out of a movie.
dominating the landscape.
Yeah, a powerful symbol of the town's reliance on electricity.
Absolutely.
And behind all of this, behind these imposing structures, was this constant stream of data.
The numbers tell the story.
Yeah, the numbers tell the story of the power station's operation.
Exactly. And the data you've gathered, it paints a fascinating picture.
We see the breakdown of electricity use.
For lighting, public lighting, traction power.
Bulk supply between 1921 and 1923.
And then later on, we get into the load factor and thermal efficiency.
Yeah. Now, I gotta admit,
Uh-huh.
load factor isn't exactly a term I throw around at parties.
Right.
Can you break that down for me?
Sure.
And, anyone listening who might not be familiar with power plant jargon.
Absolutely. So load factor, it essentially tells us how consistently the power station was running at full capacity.
Okay. Oh.
A high load factor means they were consistently generating a lot of power.
Uh-huh.
A low one suggests they had more capacity than they were using.
So if we look at the data,
Yeah.
the load factor was pretty low in the early years,
Mm-hmm.
but it seems to have increased over time.
Does that mean they were getting better at matching their output to demand?
Maybe demand for electricity was just growing faster than they could expand.
That's a good point.
It was a time of rapid electrification.
Right.
And then there's thermal efficiency.
Okay.
That one sounds pretty self-explanatory. But I'm sure there's more to it.
You're right. It basically measures how efficiently the power station converted fuel into electricity.
Okay.
So a higher thermal efficiency means less energy was wasted as heat.
Makes sense. So in the early years, the thermal efficiency was pretty low.
It was hovering around 14%.
14%. So they were losing most of the energy they put in as heat.
It wasn't very efficient, but you have to remember, technology was constantly evolving.
Right.
And over time, power plants became more efficient thanks to improvements in boiler design, turbine technology, all sorts of factors.
Yeah. So we see that gradual increase in thermal efficiency over the years. But then there's this dip in 1962.
Oh, yeah.
What do you make of that?
Well, it could be a sign of aging equipment, maybe,
Right.
or a change in fuel quality.
It's like a little mystery
It is.
hidden within the larger narrative.
And that's what makes these deep dives so interesting.
Right. You never know what you're going to find.
Exactly.
Now, before we get too lost in megawatts and kilowatts,
Yeah.
I want to zoom out a bit
Okay.
and look at the bigger picture.
The St. Helens Electricity District.
Right. This wasn't just about one power station.
No.
This was about powering an entire community.
Absolutely, we're talking about 36 square miles.
Wow.
Over 130,000 people by the late 1950s.
It's a reminder that this story isn't just about technology.
Right.
It's about people.
Their lives, their livelihoods.
And we've got some data that really shows how electricity consumption changed across the community.
Yeah, this is where it gets really interesting.
Yeah. Let's see what these numbers tell us about how electricity was being used across the community.
Okay, so in 1958,
Okay.
factories were the biggest consumers by far.
Really?
Oh, yeah. They used a whopping 339,770 megawatt hours.
That's a lot of juice.
That's more than all the other consumer types combined.
Wow. It really shows you how industrial St. Helens was at that time.
Absolutely. These factories were the heart of the local economy.
Right. Producing everything from glass to chemicals.
And all that production required a tremendous amount of energy.
Now, on the other end of the spectrum, we see that farms use the least amount of electricity.
Yeah, just a tiny fraction of the total.
I guess a lot of farms were still operating without much electrification back then.
Right, relying more on manual labor and traditional methods.
It's interesting how electrification transformed different sectors at different paces.
Yes, some embraced it rapidly while others adopted it more gradually.
Like industry versus agriculture.
Exactly.
Makes you think about how those differences in energy consumption played out in terms of economic development
And quality of life.
in different communities.
Yeah.
Now, domestic consumption also stands out.
Mhm.
In 1958, homes in the St. Helens Electricity District used over 53,000 megawatt hours.
That's significant.
Yeah. It shows how electricity was becoming more and more integrated into everyday life.
Right, electric lights, appliances,
Even early forms of entertainment.
like radios and televisions.
They were becoming increasingly common in homes.
Absolutely.
But did this increasing domestic consumption raise any concerns about the environmental impact, even back then?
That's a good question, and it's a topic that deserves more attention.
Yeah.
While the environmental movement wasn't as prominent in the 1950s as it is today,
Right.
there were growing concerns about air pollution, particularly from coal-fired power plants.
Okay, now the data also shows that even after the tram system was decommissioned,
Yeah.
there was still a considerable amount of electricity used for traction.
Traction, that's interesting.
Over 1,893 megawatt hours in 1958.
So maybe there were other forms of electric transportation still in operation?
Like what?
Perhaps trolley buses or electric trains?
It makes you wonder what the future of transportation will look like as we shift towards electric vehicles.
And other sustainable modes of getting around.
It's an exciting time for innovation.
For sure, but let's get back to the St. Helens Power Station.
Okay, the maximum demand on the system in 1958 reached a massive 93,000 kilowatts.
Wow, that's a testament to the power station's capacity.
It really shows their ability to meet those peak energy needs.
Right, but it also raises questions about the potential strain on resources.
And the environmental trade-offs involved in generating that much power.
It's a tough balancing act.
It is meeting energy demands while considering the environmental impacts.
And that's a challenge that we're still facing today.
Absolutely. Now, remember that dip in thermal efficiency back in 1962?
Oh, yeah. What do you think caused that?
It could be a random fluctuation,
Maybe?
or it could be accrued to something more significant.
Like what?
Perhaps there was an issue with the equipment that year,
Okay.
or a change in fuel quality, or even a shift in operating procedures.
It's like a little puzzle.
It is, and that's what makes data analysis so fascinating.
Now, I'm curious about the human side of all of this.
Okay.
What was it like for the people who worked at the St. Helens Power Station?
You know, we haven't really touched on that much. Yeah, imagine the workers in those early power plants.
Toiling away in the heat and noise,
Operating those massive engines.
tending to those boilers.
And as technology evolved,
They had to adapt,
learn new skills.
like when they switched from coal to oil firing in 1963.
So that must have been a major transition.
Absolutely.
Requiring new knowledge.
New procedures.
A whole new way of thinking about their work.
It's a reminder that technological change always has a human dimension.
And what about the people who lived in the St. Helens electricity district?
Yeah.
How did they experience the arrival of electricity and its growing presence in their lives?
Imagine the excitement of those first electric lights.
Illuminating homes that had previously relied on gas lamps.
And the convenience of electric appliances.
Transforming household chores.
It must have felt like a whole new world opening up.
But I imagine there were also anxieties.
Of course.
Maybe even resistance to this new technology.
Change is rarely seamless.
Right. Concerns about safety, affordability.
The disruption of traditional ways of life.
It's a reminder that the history of technology is not just about progress and innovation.
It's also about the social and cultural adjustments that accompany these changes.
Now I want to talk about the environmental impact of power generation,
That's a crucial topic.
especially as we grapple with the need for a more sustainable energy future.
Absolutely.
We've talked about air and water pollution from power plants, but what about the broader environmental footprint of the St. Helens Power Station?
You mean its impact on the surrounding landscape and ecosystems?
Exactly.
Well, that's a complex question.
Yeah.
And it's one that historians and environmental scientists are still trying to answer fully.
I mean, just the construction of the power station itself must have altered the landscape.
Absolutely clearing land for the plant transmission lines, those cooling towers.
And the extraction and transportation of fuel, whether it was coal or later oil.
That would have had its own environmental consequences.
Mining operations, shipping routes.
The fuel supply chain had a ripple effect across multiple ecosystems.
And then there's the issue of waste disposal.
What happened to the ash from those coal-fired boilers?
Or the byproducts of oil combustion.
It's a lot to consider,
It is. It's like peeling back the layers of an onion.
revealing more and more complexities as we go deeper.
So as we move forward with this deep dive,
Yeah.
I think it's important to keep this environmental perspective in mind,
Agreed.
especially as we delve into the data on electricity consumption and the power station's overall performance.
Understanding the full scope of the St. Helens Power Station's legacy, both positive and negative, requires a holistic approach.
Right, considering not just the technological and economic aspect.
But also the environmental dimension.
Well said. Now I think it's time to move on to the final chapter of this story.
Okay.
We'll explore the eventual closure of the St. Helens Power Station.
And the lessons we can learn from its remarkable journey.
Okay, so we've journeyed through the history of the St. Helens Power Station,
From its humble beginnings,
its growth and evolution.
its integration into the national grid,
We've seen how it powered a community.
and even touched upon those early concerns about the environmental impact.
But every story has an ending.
Yeah.
What ultimately led to the closure of the St. Helens Power Station?
Well, it's rarely one single factor that closes down a power station.
Right. So,
There's a whole bunch of things happening at the same time.
so like what kinds of things?
Well, you got to consider the economics,
Okay.
the technology, and even sometimes politics.
So for St. Helens, what were some of the big forces at play?
I mean, obviously, age is a factor.
Sure, power plants don't last forever.
Right. As components wear down, maintenance costs rise.
So it gets expensive to keep them running.
Exactly. But you also have to think about the bigger picture of energy production.
You're talking about the national grid.
Yeah, after nationalization in 1948,
Right.
St. Helens wasn't just serving a local community anymore.
Their operations were being dictated by national needs.
Right, so if a more efficient or strategically located power station came online elsewhere.
St. Helens might have become less essential.
Exactly.
And we can't forget about technology
Always advancing.
as new power generation technologies emerged
Older plants like St. Helens might have struggled to compete.
in terms of efficiency and cost.
Right, it's adapt or become obsolete.
So what happened to the site after the power station closed?
That's a good question, and it really speaks to the legacy of these industrial sites.
Did they just abandon it?
Sometimes they do.
Or did they repurpose the land?
Often that's what happens. They demolish the old structures and reclaim the land.
So maybe it became a park
Could be.
or a shopping center.
Possibly.
It'd be interesting to see what it looks like today.
Yeah, the land holds a history.
A story waiting to be uncovered.
Makes you think about all the footprints we leave behind.
Not just physical ones, but the impact we have on the world around us.
That's a good point.
So as we wrap up this deep dive,
Yeah.
what's the big takeaway for you?
It's the interconnectedness of everything.
How so?
We started with this seemingly local story about a power station, but we've seen how it's connected to national policies, technological advancements, economic forces.
Structural change.
It's all intertwined.
Like a ripple effect.
Exactly. And those ripples continue to this day.
As we face the challenges of climate change,
The transition to renewable energy.
the lessons of the past are more important than ever.
So what lessons from St. Helens should we carry with us into the future?
I think the big one is that energy choices are never just about technology.
Right. They have social, economic, and environmental dimensions.
It's about finding that balance.
Meeting our needs while ensuring a sustainable future.
And that requires innovation, collaboration, dialogue.
A willingness to learn from the past.
So for our listeners out there,
Yeah.
what final thought would you leave them with?
Think about your own relationship with energy.
Where does our electricity come from?
What are the impacts of our choices?
And what role can we play in shaping a more sustainable future?
We all have a part to play.
Well said. Thanks for joining us on this deep dive into the St. Helens Power Station.
It's been a pleasure.
Until next time, keep exploring.